everyone, this video is going to be a little bit special. I wanted to have a conversation about my predictions for what was going to happen in the field of computer science in 2025. But before we get into that, it's important to talk about why you should try making predictions. Basically, humans are really bad at making predictions. They really fall prey to the hindsight bias, where basically they look at past events and think, oh yeah, I totally would have predicted that exact outcome, but they're seeing it from the future, so they know what happens. In fact, Sam Altman has a really good blog that basically just talks about famous historical figures and really bad predictions that they made that absolutely didn't come true. It's really entertaining to read, so I'll link it in the description of this video. But what I think is the only viable way to test your prediction abilities is to make forward-looking, falsifiable predictions and then later looking back and seeing if they came true. So this is going to be a really casual conversation. I'll also release a blog post that goes kind of into more detail and talks about my predictions more. And I'll leave that in the description of this video as well. So let's get into it. Let's talk about what I think is going to happen inside of the RISC-V space. So basically, there's very few actual packages compiled specifically for RISC-V at the moment. And out of all of the major Linux distributions, I really only know of Debian that has like an official RISC-V release build. But I think over the next year, that's probably going to start to change. I think that more people are going to be compiling packages for RISC-V as the demand for it grows. So my prediction is that at least 3 major Linux distributions are going to add official releases for RISC-V, and not just community releases of these. You might have seen in past videos that I've played around with RISC-V boards quite a bit, and I've noticed that the software capabilities are just incredibly limited, and it's like, oh, do you want this one specific version of Python, and basically this is all you can do on the board? But I think that's probably going to change, and hopefully people add more support and actual compiled applications specifically targeting RISC-V. Now I want to talk about this from a hardware perspective. I think because of all of these limitations, there's probably less than a 20% chance that the Raspberry Pi Foundation comes out with a primary SBC running a RISC-V SoC. They have a current good relationship with Broadcom, but Broadcom only manufactures ARM CPUs, not RISC-V CPUs. So this might potentially make them be concerned about supply chain difficulties. Not only that, but they might also be concerned from a software perspective. Basically, they're so established, they want to have as much backwards compatibility as possible, but because of the limitation of how much software is actually compiled for RISC-V, they might not be positive that they're actually going to be able to maintain this support and backwards compatibility across all their devices. I do think there is a very small chance that they come out with a secondary Raspberry Pi. Wow, windy. Maybe like a Raspberry Pi Zero that's running a RISC-V CPU, but I do think that's a very small chance. Now I want to talk about cryptography. I think there is a 70% chance that NIST comes out with new guidelines advising federal agencies as well as their contractor to start using quantum-resistant cryptographic algorithms. Symmetric encryption is relatively safe against these kinds of attacks. It really only reduces the complexity by half, which means that AES 256 pretty much becomes AES 128. Asymmetric encryption algorithms, on the other hand, like for example RSA, are super vulnerable to these kinds of attacks. Adversaries tend to have a kind of forward-thinking approach to these kinds of attacks where they collect data now in the thought that they'll be able to brute force it sometime in the future. So that means that encryption standards also have to have this kind of forward-thinking approach where they need to be more secure ahead of time in prediction of what they could potentially be trying to deal with in the future. So just because quantum computers aren't able to crack something now That doesn't mean that in 10 years you won't be able to have the kind of capabilities to brute force that in the future. Now let's talk about the hot topic of memory safety. My prediction for 2025 is that even though there's been this really big push towards memory safety, the majority of existing code bases are still going to be in memory unsafe languages like C++, for example. However, for new code bases, let me not get run over by a car, they're going to be written in memory-safe languages like Rust or Go. Now that kind of kills my soul because I do really like C++, but I think that it's going to become less and less popular for developing new applications in C++ directly in the future. But people really underestimate the amount of legacy applications that are out there that are written in these languages. I mean, think of it. You've had years and years of applications written in all these kinds of older languages that nobody really thinks about anymore. But somebody needs to keep on maintaining those and potentially even add new features to those existing applications. I remember quite a few years ago when I was in school, I was talking to my friend's dad, and he worked for a large company, and his sole job was basically taking their legacy PHP code and trying to translate all of that to Python. So that's thousands and thousands of lines of code that he's basically just translating to the latest language at the time. That's also why I think that it's still going to be a demanded skill having knowledge in these legacy memory unsafe programming languages, because you have to be able to have developers who know these languages and are able to maintain existing code. I've actually seen a lot of new developers coming to this space really having no knowledge of legacy programming languages and pretty much just focusing on the main languages at the time of like Go and Rust, for example. In fact, there's actually been quite a few government contracts specifically for translating legacy memory unsafe languages over to memory safe languages. Hey, it's a person train. Train, here we go. Train. I like it when they're people trains because they go faster. Trains are really cool, although I wish it was a coal train. Okay, now let's talk about the next hyped up programming language. And for the last couple years, the main hyped language has been Rust, like every single time. So I'm going to use two different metrics to try to define hyped up current language. The first metric is going to be the number of new Stack Overflow questions that are tagged with a particular programming language. And then the second metric that I'm going to use is the number of new members joining a particular language's subreddit. And I'm going to do this based off of percentages. Now, my prediction for 2025 is that even though Rust has been the main hyped up programming language for the last couple of years, it's actually going to have less percentage of growth than Zig, which is another up and coming hyped up programming language. Part of my thought process behind this is that most hyped up programming languages have about a 3 to 5 year time of growth and time of hype, and Rust is actually reaching the kind of end of its maximum hype time. And you really see this kind of same pattern time and time again. For example, Ruby and Scala definitely had a period of boom time and reached their maximum, I would say, boom capacity after that amount of time passed. Now I want to talk a little bit about compression. I think that by the end of 2025, at least two major streaming platforms are going to use AV1 as their default codec for both HD and 4K on supported devices. It's really the logical next step after H.264. Actually, Twitch has already been experimenting with this for the last year, and the results are doing really well. Fun scooter. The reason it's so appealing to streaming platforms is because it saves a significant amount of bandwidth for about the same level of quality. I think there's a really small chance, maybe like 30% chance, that a major streaming vendor pairs up with a TV vendor or a set-top box or maybe a hardware vendor like NVIDIA to certify a device for AI upscaling. So you might not be aware, but AI upscaling has been around for A pretty decent amount of time, and one area where it works really well is upscaling older animes that might not have been released in HD, for example. So basically, if the quality is really bad, you can upscale it, and it makes it look almost like it was actually released in HD, which is pretty nice. Oh, helicopter. There's also another feature that you are probably not aware of that's part of Microsoft Edge, and there is an AI upscaler, but it's built into it and set off by default. So you have to go through and enable it if you want to try it out, but it'll work on your videos and apply to maybe a YouTube video you're watching if you have the quality set really bad or it's a super low quality video, to automatically upscale the video. And it actually works surprisingly well. So I think this is going to be a really interesting feature going forward. Now, I talked a little bit about AI upscaling, but now I want to talk about generated AI content. And I think, just like we've been seeing, we're going to continue to see a major increase in how much generated AI content is really taking over. We've really noticed this a lot inside of the image industry as well. Like if you're looking at stock images, that pretty much has been made obsolete in my opinion. Basically everybody that I talk to is thinking, wow, I can just use generated images inside of my presentations, inside of anything that I need it for, and it's customized exceptionally for my current needs. Now, one area where I think we're going to see an increase that a lot of people aren't really thinking about too much is in kind of stock music. So think about it, if you're watching a YouTube video, for example, usually there's not just dead silence. Usually you hear background music, even if you're not consciously aware of it, but you don't think about the amount of copyright challenges that are happening on this kind of background content that you're subconsciously enjoying. Now, I think that we're going to have an increase in the amount of AI-generated background music for content creators, and that's going to really make things, I think, a lot easier to avoid copyright issues. One thing I don't think is going to happen is I don't think there's going to be a huge increase in the amount of AI-generated videos that are used for stuff. The field is really just not super amazing yet, and I think the next logical step is going to be the background music industry. To kind of stick to my own advice and try to make this prediction quantifiable, I think that there is an 80% chance that some major stock music provider is going to add a custom AI-generated, copyright-free background music option as a part of their site. So it's not going to completely take over the entire stock music website, but it's going to be a new feature that's going to allow people to have an easier time with copyright. Now, last prediction on this point, I think there's probably about an 80% chance that some major AAA gaming company uses LLMs to enhance their NPC interaction. So when you're talking to an NPC and having a dialogue with them, I personally think that would be pretty cool. That means that it's kind of like a customized version for every single person, and you basically get your own experience when you're playing a game. But the side benefit to this that probably not a lot of people would think about is that it could potentially enhance digital rights management and protection against cracking games and stuff, because I wouldn't think that they would be using local models. They're probably going to use models that are hosted in the cloud somewhere, so that means it has to constantly have a communication with the back-end model to be able to function properly. So if you've pirated the game, you're not going to be able to get that custom interaction and experience. Now, one thing I want to talk about are supply chain attacks. And supply chain attacks are particularly interesting to me because not only do they affect a single application, but let's say there's some really large vulnerability or potentially some malicious code slipped into some really popular library. Well, now it not only affects that library, but it affects anything that depends on that library as well. I think there's two major supply chain attacks that really stand out in my mind. The first is SolarWinds, and the second is Log4j. I was working at Microsoft during Log4j, and I just remember it was basically like the entire world was on fire, and everybody was trying to come up with all these different potential fixes to remediate the vulnerability. But at the end of the day, like with most of these things, the solution is just going to be for the library to issue an update to either remove the vulnerability or get rid of the malicious code inside of it. And then after that, every single application that depends on that really needs to update itself to be able to get the fix. Now that sounds pretty simple, just hello, update your software, but it really does not end up being that simple, because just think of the thousands of applications and machines that potentially need to be updated at that point, and it becomes this really large logistics problem, which is why I think in 2025 SBOMs are going to become a lot more of a thing. I think that probably at least 3 of the major Fortune 500 tech companies are going to publicly announce that SBOMs are a contractual obligation and deliverable for their third-party vendors. Now, SBOM stands for Software Bill of Materials, so it basically just means that you have to list every single dependency that your application has, and you know what versions they're running, where they come from. But not only that, you have to list what dependencies do your dependencies have, because a supply chain attack could affect any of the dependencies or their dependencies. Think of it like having a cake. Let's say you were eating a cake and you realized that your cake was poisoned and you got it from your neighbor. Well, if you implemented an SBOM type thing, now you're starting to think about what ingredients are inside of your cake and where do those ingredients come from? Because if you got a poison cake once, you never know if it's going to happen again. So you're starting to pay attention to the individual ingredients and details so that you can ensure quality going forward. Now, this is actually already pretty common inside of the government space. A lot of agencies make it a contractual requirement for their contractors or vendors to have SBOMs as a deliverable. This also ensures that if you are affected by a supply chain attack, if you know exactly what and what version of software you're running in like every single machine, you can quickly see if you're affected by a supply chain attack and then update the library once you know the fix has been released. Now, the nice thing about SBOMs is you can basically instantaneously let your customers know if you're affected by a supply chain attack. Without SBOMs, you wouldn't know what software you're running, you wouldn't know what versions of software you're running, so you pretty much have to do this extra quick inventory check to see if you're affected by an attack that's currently happening that people are worrying about. He's got some Zorro looks going on. All right. Now I want to make a prediction in the reverse engineering space, because that kind of lies close to my heart as my current career path. And I want to talk about how LLMs are going to affect reverse engineering in 2025. Now, I think a lot of people want to be able to take an application and feed it to an LLM and have the LLM basically just explain what an application is doing, maybe offer an approximation of what the code looks like. But that's just not how LLMs really work with this kind of stuff. You can't just upload a compiled application and expect it to know what's going on. The term language is actually in the name, so it makes sense that they'll be able to work better with language type tasks. Now, my prediction for 2025 is that at least 2 of the major decompiler applications are going to offer automated method name suggestions. So basically, if you're trying to look at an application and you're looking at a method inside of it, LLMs are really good at identifying what this method is doing without too much context, and then maybe offer a suggested name for that method. Or also, if the method belongs to a popular kind of library, for example, let's say it's actually printf and you're just looking at decompiled code for printf, it can give a suggestion on what you should name that function and identify that it belongs to something. Now, one thing I'd really like to see that I don't think is going to happen is automated code translation. Now, if you're decompiling an application, you're basically looking at an approximated C code version of any given function. Regardless of whether that function was written in another programming language, you're seeing this sometimes really terrible approximation of a method. Now, LLMs are surprisingly good at taking in ugly decompiled code and translating it to what it thinks the original native code would actually look like. So you could look at an approximated version of what this method is in Swift, for example. Now, I don't think this is going to actually happen because I was at a security conference this year and I was talking to the creator of IDA, which is one of the primary decompilation tools in the industry, and I pretty much suggested this as a really cool feature that would be nice to have, and he really did not go for it because he was saying it removes the accuracy. And I do agree there, because LLMs will provide non-deterministic responses every single time. But sometimes you basically just want to get a quick approximation of what a method actually does, and you're not always focusing exactly on the accuracy of the code that you're looking at. Now, part of the reason I'd like to see this is because I did make this a feature of my open source iOS decompiler called Malamite, where you can request an approximated Swift or Objective-C version of the method that you're currently analyzing, and it actually works really well. It's a nice view of the Space Needle. Cool. Anyway, I think that's about enough for right now. I know this has been a lot of information and talking about a lot of different topics inside of this video. As I mentioned, don't forget to check the description of this video for a link to the blog post where I go a lot more in depth, since right now it's just kind of me chatting and thinking about things. I also really want to hear from you. What do you think? Do you think I'm completely wrong on topics? Do you agree with some points that I have? Feel free to let me know inside of the comments section of this video. And until next time, Lori Wired out.